All right, in today's video, we're going to be showing you how to build a star schema using polars. And so we're really excited to share that with you. Now, before we jump into that, I do want to invite you, if you're new to the channel, to go check out the Polars Code Academy repo on GitHub. On there, we keep all of our Jupyter notebooks, all of our CSV files, the things that we use on this channel and in our videos, we keep all on there so that you can follow along and have that real world experience for yourself. So go ahead and check it out. And let's go ahead and jump into the video. Alrighty, so talking about star schemas today, we're going to build one with polars and all the polars functions that kind of make that somewhat easy. And so we're going to be going into a lot of the more building detail. We're not going to be really talking much about the principles behind star schema or why you would use them. So if you're looking for that, maybe find a different video first, and then come here. You can learn how to actually build one very quickly using polars. Okay, so just as a brief overview, how star schemas work is you have your centralized fact table. These hold your metrics and items that you can aggregate on, different things that provide more of a quantitative type feel for your analytics. Now, each of these star points are dimension tables, and those describe the transaction, so to speak. So if your grain, to use one of the star schema terms, if your grain is to show, for example, we're going to be going through order IDs, you might want to have dimensions that talk more in depth about those orders, but you don't necessarily want to put that on the fact table, so you put those on the dimension table. So that's what we're going to be going through today. Let's go ahead. We're going to start by importing polars as PL here. Okay, and now that that's loaded, we're going to actually, sometimes we use CSV files on the channel and we do the read CSV function. In this case, we're just building a data frame from scratch here and have all the data sitting in here. So we're going to call this one stage sales. So we're going to create a sales dimension, or excuse me, sales fact table with various dimensions that are pointing to it. So let's go ahead and put that into a data frame and visualize what that looks like. Okay, so within here we have certain items that could be metrics, right? We've got the number or the quantity over here and the unit price. Those are basically going to be, and there might be one other in here. I can't tell. I'm not seeing anything. The rest of these are mostly going to be dimension tables, right? So these are going to be part of the fact table. And then we're going to build out all these other dimension tables. And how we're going to do that is we're going to, for example, at this customer part, this customer ID, we're going to grab these three columns because they relate to customer, and we're going to break them out into their own dimension table. Now, when we do that, we will create a surrogate key. So they do have a ID here, but we are going to create a surrogate key that will replace that and make it an integer. And the reason we're going to do that is for reuse. You can see on here there are some repeat customers here. And so this is taking up a lot of real estate and memory if we store it in one table. But if we turn this into a surrogate key, in other words, an integer value, then it's not taking up as much space on your database. So that's one storage aspect of star schemas. There's other reasons why you want to do that, but retrieval is the other one. If you're trying to query this data and having all three of these columns in one spot, it takes up so much more memory to pull that from the database. So anyway, so this customer ID is going to be one. We're going to have a product one. We're going to have a store one as well. And then we'll also have a date dimension table that we'll talk about here. Okay, so that's a brief overview of kind of the direction we're going to go. Let's go ahead and come down here. And the first thing we're going to do is create a date dimension table. Now, this is commonly used in analytics when you're trying to roll up data into kind of an easy to digest time frame. For example, maybe you're doing quarter reporting or month-end reporting, and you need some of these values in here to kind of do that. So what we're going to do is we're going to pluck from this order date table, and we are going to create a date key, and that date key is going to replace ultimately this, and essentially what the date key is going to be is basically the exact date as it's showing here, except without the dashes, and that's going to be our date key. And you can see that's what we're doing here. So we're doing year, month, day, and then we're casting it as an integer value so that it stores not as text. And then we're adding on a few other items here, right? So we're using a lot of the date time functions to get some more dimensionality to these different dates. So we want to know, okay, what month is this a part of? What year is it a part of? What day? Again, I mentioned quarter reporting or fiscal year reporting, different things like that. You can put into your date dimension table, and then it will allow you to roll up your data into those aggregations. So if you wanted to aggregate the unit price and aggregate your sales for that, you could do that here. Okay, so let's go ahead and run this and show you what it looks like. Okay, so this is the date key, as we talked about. It doesn't have any dashes. And then we've got all these other ones that are telling us different dimensions about these specific dates. Okay, let's move on to customer. Now, we did kind of talk about this a little bit more in depth, but let's go ahead and actually talk through the plan for this one. So we have the customer name, we have the customer segment up here, and we're going to put those into their own table, their own dimension table. So one thing that we do want to do is we want to create a surrogate key. And so what we're going to do is we're going to sort by the customer ID here. We're going to grab the unique values from that, and we're going to create a customer key and increment it by 1. So that's what we're doing here. And so let's show you what that looks like in the output. Okay, so now instead of having, we have several values here. We have essentially 4 customers. And you can see we still have the existing customer ID from the system that it came from, which is important. You want to keep that around. But now we've created a surrogate key that's going to save us some space and make querying a little bit faster when we're working with the sales fact table. Okay, product name is going to be very similar. We're basically going to pull out all of the product information up here. So we're going to create a surrogate key for the product. Then we're going to keep the product SKU, the product name, category, and then that's it for the products. So let's go ahead and run that. We're doing the same thing before I run it. We're doing the same thing here with the incremental key. And then basically we just want to get those unique values. So let's run that. Okay, so 3 products total. And this could grow. One thing about dimension tables and star schemas is this product table could grow, and you would want to add in maybe a 4th, 5th, 6th product. And that's easier to do when you do it in the star schema. So anyway, just a quick thought there. Let's talk now about the store dimension. So that's where, if scrolling back up to here, we've got our store codes, store name, and the region that they're in. So this is particularly useful if you're doing reporting for, regional managers. They want to say, hey, how are my stores doing? They roll up into the region. That's one hierarchy that you could kind of pick out here with the store. But we're going to do a lot of the same stuff, right? So we're going to take that store code and we're going to sort, and it looks like we're going to be sorting alphabetically. We'll double check that that's the case here. But we need to also create a surrogate key like we've been doing. So we're doing the with row index, and then we're offsetting it by 1, saying, okay, increment by 1. So start at 1, go 2, 3, 4, etc. Okay, so let's show you what that looks like. Okay, so 3 stores, and it does look like they are alphabetically listed here. Doesn't really matter. The important part is that on your actual fact table, you're referencing the correct key. So, for preference, if that's how you want to do it. The other thing is, say you add a store that's a new store that's in Dallas or whatever, you're going to have it not be in alphabetical order. So again, not super important there, but there needs to be some sort of surrogate key system in place there. Okay, so now the fun part is going to be creating our fact table. Now this table is going to essentially hold just the metrics that we want to have in there, and then it's going to have all of the dimension keys that we just created. So let's talk through what's going on here. So we are going to be we've got the stage sales, and then we're joining all of these new tables that we have. Okay, and then we're connecting to those keys and making sure that we correctly code those on there. And then down here, we're selecting the ones that we want to keep within this new table that we're creating. So it looks like a lot going on. It's really pretty simple. We're just taking the tables that we created, inserting the surrogate keys that we generated, and then we're grabbing the specific dimensions that we want to see here. The one note I will make here is the quantity and price. We are doing some arithmetic here, making sure that we get the total sales amount, because that's actually the metric that we want to follow there. So let's go ahead and run this so you can see. Okay, so again, we added in all the surrogate keys, so now we've just seen numbers here. And arguably this doesn't look as, it's not as easy to understand, right? Because you have to join to those other tables in order to do it, in order to understand what's going on with it, I mean. But it does help with storage and with query times. So rather than having to, when you're building analytics off of this stuff, rather than having to go in and query all the data, including the text and everything, all in one table, you can reference the keys that you need, and then that will pull in a little bit. Well, I shouldn't say a little bit, a lot faster, right? That's the whole purpose of doing the star schema. Okay, so we did add in the quantity, price, and sales amount here. So these two were here before, but we did calculate the sales amount, and that's a new metric on this fact table, and that's going to be really key, because then we can aggregate basically on any of these dimensions here and get an idea of, okay, how is sales doing by customer? How is sales doing by product? How is sales doing by store? And we have these different, or even by date. I didn't even mention that one. Date's probably the most important, right? How did we do this week versus last week? Different things like that. Okay, enough talking there. Let's talk about how you could actually query this. So now that you've built out the star schema, you do need to join back to those other tables that you created. And so let's say that you wanted to do some aggregation here. So I'm going to run this and we can talk through it. This one is grouping by the month and the product type. So we're getting the total number of sales based on those two dimensions, and pretty quick that it ran there. And granted, this is all in memory; it's really small. But when your fact table is very large and you're doing large scale analytics, that query speed is really crucial. So anyway, this is a really unique and effective way to, I shouldn't say it's unique, it's really common to use fact tables. But it's a great way to structure your analytics, and Polars makes it really easy. You can see how quick we were able to create those surrogate keys and build everything out. Alrighty, that's all we had for this video. If you liked it, please check out our other videos and subscribe to the channel. We'll catch up with you at the next one.